This video is on solving quadratic equations, and we're going to be using the square root method. So when we are using square root method, we look to see if there are parentheses as well. So when there are parentheses, you should get the parentheses alone, take the square root, then solve the two equations. Because when you are solving, especially using square root method, you use SADMAP. You cannot touch the parentheses or inside the parentheses until you've done everything else. So what we want to look at is we have one letter P in this problem and no other P anywhere else in the problem. That means that we can just solve for the single letter P. We don't have to try and factor it. This should just give us something nice and easy. So we look for the parentheses. We have parentheses. And we want to get everything away from it. So we have nothing that we can add or subtract away from the parentheses. We have nothing that we can multiply or divide away from the parentheses, but we do have the exponent on the parentheses. So let's get that exponent away from that parentheses. So we have p minus 4 parentheses squared is equal to 16. So to get that square away, we will take the square root of both sides. And as a reminder, when you take the square root of both sides, you should have a positive and a negative on that answer. So we'll have the square and the square root will be able to give us to a 1, so we'll get to p minus 4 is equal to. We have to have that plus or minus on this side because we're taking the square root of 16. So we know that the square root of 16 is 4. What this really means is that we have two parts, because we're going to have then solve two equations. We have that p minus 4 on the left is equal to a positive 4, and we also have that p minus 4 on the left equal to a negative 4. So we have two equations, and this is how we get our two answers. So if we continue solving for p here, we're going to add 4 to both sides, and we'll have p is equal to 4 plus 4 is 8. On the other one, we're going to add 4 to both sides. And we'll have p is equal to negative 4 plus 4 is 0. So our two solutions are p equals 8 and p equals 0. So what we did was we got the parentheses alone, and then we were able to solve two different equations. So on question 7, we're going to find the parentheses and the exponent. We look to see, is there anything we can add or subtract away from the parentheses? There's not. Can we multiply or divide anything away from the parentheses? There's not. Now we can get rid of the exponent. So I'm going to rewrite this as parentheses 2k minus 1 parentheses squared is equal to 9. So we want to get rid of the square by square rooting both sides. So we're going to be left with the 2k minus 1 is equal to, since we took the square root of both sides, we have to put that plus or minus, and then the square root of 9 is 3. You got to be careful about actually doing that math. Now we just split it into our two equations. So we have the left of 2k minus 1 is equal to the positive 3, and we also have the 2k minus 1 on the left is equal to a negative 3. So now we go about solving this. So let's solve this first equation over here. We're going to add 1 to both sides. So we have 2k is equal to a positive 4. And then we're going to divide by 2. So we'll have k is equal to a positive 2. 4 divided by 2 is 2. We're going to do the same thing on this side. So let's go ahead and solve it. We're going to add 1 to both sides. We're going to have 2k is equal to negative 3 plus 1 is negative 2. We're going to divide by 2 to get k alone. So k is equal to negative 1. So our two solutions are k equals 2 and k equals negative 1. On the next problem, we're going to do the same thing. We're going to look at our parentheses squared. We need to get everything away from it. So we do have a subtraction of 20. We need to move that. So we're going to, since this is subtraction of 20, we're going to add 20 to both sides. So we still have 3 parentheses x minus 6 parentheses squared is equal to positive 3, because negative 17 plus 20 is positive 3. So we still have that parentheses squared here, which we still have that multiplication of 3 attached. So we need to divide by that 3 on both sides. And we'll be left with parentheses x minus 6 parentheses squared is equal to a positive 1. We've now added, subtracted, and multiplied, divided away. Now we can get rid of the exponent. So to get rid of the exponent, we're going to take the square root of both sides. We'll have x minus 6 is equal to the plus or minus, because we took the square root of both sides, the square root of 1 is 1. We'll break this into our two equations. So the left of x minus 6 is equal to the positive 1, and the left of x minus 6 is equal to the negative 1. We will solve this side, so we're going to add 6, add 6. We'll have x is equal to 1 plus 6 is 7. And on this side, we're going to add 6, add 6. So x will equal to negative 1 plus 6 is positive 5. So our two solutions are x equals 7 and x equals 5. On this next question, so again, we have only one letter x in the entire problem. So we're going to circle the parentheses and the squared. We have, even though this is a negative 3, this is not subtraction, this is a multiplication. So we have nothing added or subtracted away or on it, so we want to multiply and divide. We have negative 3 times this side, so we need to undo that multiplication by dividing by negative 3 on both sides. So negative 27 divided by negative 3 is a positive 9, is equal to a parentheses x minus 2 parentheses squared. Now that we have everything added, subtracted, multiplied, divided away from here, we can undo the square by square rooting both sides. Now, this problem is just written backwards from the other ones, but we do the math the same way. So we're going to have x minus 2 on the right-hand side is equal to, since we took the square root of 9, we're going to have the plus or minus, and then the square root of 9 is 3. So now we set our two equations. We have a positive 3 is equal to the x minus 2, and we also have the negative 3 is equal to the x minus 2. So to solve for this x, we're going to, on this left side, we're going to add 2 to both sides. We're going to have x is equal to 3 plus 2 is 5. And for the second equation, we're going to add 2 to both sides to get our x by itself. We'll have x is equal to negative 3 plus 2 is a negative 1. So our two solutions in this case are x equals to 5 and x equals to negative 1. We did the math the same way, but it was just backwards because it was written on the other side. And it's still perfectly fine to do it this way. If you feel more comfortable taking this, the negative 27 and the negative 3 times x minus 2 squared and flipping them and actually putting them on the other side of each other to make it look like 6 through 8, you're more than welcome to. So on this last one, the question is really asking which of the following could be solved using the square root method algebraically. So we just want to circle all of them that we can use the square root method. As a reminder, the square root method can be used if there is literally only one x in the entire problem, meaning there's no bx term. We can have a ax squared or just one single x. So if we look at question A, we have a 4x squared and a 3x. What happens here is because we have two completely different x values, x squared and x are completely different, this part makes it bad. So we cannot solve A by the square root method. We could potentially factor that, but we can't use square roots. On B, we have 2x squared equals 8. We have one physically written x in this problem. That means that we could use square root method to solve this. On question C, if we look at all the variables, we have an x here and no other x. And that means that we could use the square root method to solve this because there's only one physical x written in the problem. On D, we have an a and an a squared. Those are two completely different types of a's. Therefore, we cannot use the square root method because of this piece right here. Because this is a completely different a than a squared, we cannot use the square root method. Again, we could potentially factor this, but we cannot solve it using the square root method. On E, we have a c here. It's squared, and there's no other c in the entire problem. Therefore, we can use the square root method. On F, we have an m squared, and there is no other m in the entire problem, so we could use the square root method to try and solve this. On G, we have a b and a b squared, so these are two completely different b's. That means because of this additional b, we cannot do this. This is bad. On H, we have an x squared and no other x's in the entire problem, so that means we could actually use the square root method to solve this. So again, square root method is when there is one physically written letter in the problem, or if there's multiple, they're the same exact letters. So an x squared and another x squared. But an x or an a and an a squared are two completely different types of letters, so we cannot use square root method on that. But if there's one physical x written, we can just solve that problem just using SATMEP.